right, we're on to the legal pad. I've run out of blank white paper. The natural logarithmic function. Okay, so we've been working with log, L-O-G. This is going to be the natural log, or Ln. Right, it still has the same, you can look at it like this. It's to the base of e. So you can look at it as log, base e, so e to the what equals x. Okay? That's going to be equal to the natural log of e. And let's look at properties of it, and then we'll do some examples. Properties of natural logarithms. All right, so if we have the ln of 1, that equals 0. Okay, e to the 1 equals 0. I'm sorry, e to the 0 equals 1. It's confusing for me too. All right, the natural log of e equals 1. E to the 1 equals e. And the natural log of e to the x equals x. E to the x equals e to the x. All right, so again, they become less confusing once you see some concrete examples, okay? Kind of like with all of math. The natural log of e squared. So that's just gonna look like, well, I don't give you a lot here. The natural log of e squared equals 2. All right, let's look at the next one. The natural log of 1 over e. 1 over e, I kind of smushed in there, equals the natural log of e to the negative 1, right? 1 over e. So there it equals negative 1. So you're kind of happy when you see a natural log problem, okay? E squared, it's 2, because you're always looking for the exponent in logarithms. And 1 over e, e to the negative 1, it's negative 1, okay? Let's look at the graph and then the change of bases. I'm not sure how much we get into change of bases on homework, but you need that for pre-calc. It comes up a lot. So if I'm going to graph f of x equals e to the x, okay? Then e to the 0 equals 1, okay? And e to the 1 equals 2.72. So it looks like that. And then if we look at the inverse of it, so if we're graphing ln of x, this is f of this is e to the x. And then if we're going to graph ln of x, okay, which would be the inverse, we can just reflect that over y equals x. And that's the ln of x. All right. Okay, so let's look at the change of base formula. I keep talking about it, so let's look at it. And so you know where we're going, you have a lecture tonight, Tuesday, one on Thursday, one the following Tuesday. Then the next 3 Tuesdays and Thursdays, you'll be working on your project with your partner, because that would have been my high school spring break, but Florida doesn't want New Jersey people to go there anymore. After that, when we come back, you have 3 more lectures, Tuesday, Thursday, Tuesday. And then that following Thursday, we'll review, and then your final will be that next Tuesday, May 5th, okay? All right, change of base formula. So this is when your base isn't 10, and your calculator won't take it, okay? So if you have log base A, so a to the something equals x, what you're going to do is you're going to say log to the base b. It's going to be 10, all right, of x, so your exponent, and log to the base b of a. You could also look at this as log to the base a of x equals the natural log of x over the natural log of a. It's actually more straightforward this way and less confusing. So let's look at some concrete examples. Okay, so we want to evaluate the log base 3 of 5. Okay, 3 to the what equals 5. If my battery's running low, so if you missed that. 3 to the what equals 5. So how we're going to do that is we're going to say log base 10 is 5 over log base 10 of 3. Okay. You would then put it in the calculator and you would do 5 log divided by 3 log. Okay. So 5 log divided by 3 log. And that's going to equal 1.465, let's say. Okay, that's a point in there. All right, and then if you had log base 6 to the 2, okay, then you would do, you could also do it this way, in a different way. The natural log of 2, over the natural log of 6. Okay. Again, you're going to plug that into the calculator, and it would look like 2 ln divided by 6 ln, and you would get 0.387. Okay, so that's when, like, now if this was easy, right? If your base was 6 and it was 636, well, 6 to the what equals 36, 6 squared, okay? It's when it's not easy, all right? And your base isn't 10. So you want to do log base 10 of 5 divided by log base 10 of 3. Okay, if you look at the formula and try some, you'll be okay with it. All right, so then we're going to move on to section 9.4, which is properties of logarithmics, and I will get that in the next snippet for you all.